Good evening, everyone. Welcome to Sky Observers Hangout. We are so happy. And I'm the Director of Public Observing here at the Adler Planetarium in Chicago. And with me right here is...
Yes, hello everybody. I'm Hunter, Public Observing Educator here at the Adler. We also have a couple of Adler friends joining us in the chat today. Jennifer is going to be our chat moderator tonight. We've also got Geza joining us in the chat. He's one of our local astronomers here at the museum, and he will be joining us today helping answer some questions. So what you'll look for in the chat for those is if you see the little yellow Adler logo next to it, that's Jennifer. Look out for her out there. And then Geza will have a little blue wrench next to his name. So keep an eye out for both of those names tonight. Geza will be a huge help answering questions. So make sure to leave them in the chat if you have any.
Exactly. And by the way, we're doing this from the observatory. If you didn't happen to notice, we are here at the Adler. If you're seeing us in different places, it's because we have a camera here, a computer here, and another screen here. And
I was going to say, yeah, watch out for the computer screens in the back too.
And yeah, you keep looking out just to see if there's any possible chance of seeing this. There isn't. It's cloudy right now. So anyway, we just went off script for a second. We've got about an hour and 10 minutes to kill. So I hope you don't mind that we have that little part right there. But we want to tell you, especially if you are new to Sky Observers Hangout, this is your place. This is our place to gather together to nerd out about the sky. And our goal is to give you practical tips and information to help you be able to learn something new about sky observing. And so if you have questions, we love questions. Sky Observers Hangout is here because of questions. And if you can, please do that. If you just want to sit back and relax and watch the show, that's okay. But the questions, throw them in the chat. We've got folks behind the scenes who are going to feed us the questions, and Gay says they're answering questions too. One way or another, we will do our best to answer your question. But this is how Sky Observers Hangout works. We want to nerd together about the sky. So anyway, while you're doing that and while you are thinking of your questions, and hey, we want to know where they're tuning in from, right?
Yeah, absolutely. So before you ask questions, let us know where you're joining from tonight. Post in the chat where you're joining. Hopefully it's not as cloudy there as it is here on the lake in Chicago. Also want to say you can help us get more visibility for our shows by hitting subscribe right below us to the Adler Planetarium's channel, as well as if you like the content today, give us a like on the video as well. Doing this helps you stay in the know. You'll get to see future Sky Observers Hangouts coming right on your YouTube page, but also helps get the word out to everybody else, because we'd like to think that they would want to know that we're live too, right? So lots of things to do, and yeah, make sure to post in the chat where you're joining from today.
And we're going to do a few shout outs to folks who are out there in the audience. We'll do that in just a second. But hey, by the way, the Adler Planetarium's open. We reopened earlier this year. So Jennifer's going to put a link in the chat if you want to purchase admission tickets and come see us sometime. And we are here at, like I said, at our observatory. We were hoping to watch the occultation of Mars, but we think it's actually pretty cloudy in a lot of places across the country. We're looking at the cloud forecast. We were trying to contact all sorts of folks, trying to go, hey, is it clear where you are? Nope, it's foggy in DC. Hey, is it clear where you are? Nope, it's cloudy out here in Aurora. I mean, it's just, it seems to be cloudy everywhere, but hey, that's what we get, right?
Yeah, that's how it goes sometimes. You know, it's astronomy, you know, there's only so much we can do. We did our planning. Now, fortunately, there will be lots more occultations in the future that we can check out. So this isn't your only chance. I think the next one that's visible in Chicago is in about 2 years from now.
Yeah, January 2025. So, you know.
There will be more chances. Yeah, it's not necessarily a once in a lifetime thing. Well, it was exciting, but not necessarily a once in a lifetime thing.
But we've got the roof of the observatory open, and actually we can show you that in a little bit. So we got the roof, and I keep looking up just on the off chance that there's something up there in the sky. No, there isn't, but that's okay. So you want to see where a few folks are joining us from?
Oh yeah, absolutely.
Oh, by the way,
I was gonna say, I pulled up here. This is the view through our camera here tonight. I figured I'd at least share our screen. So just in case we do get to see some moon tonight, it'll be here. Right now you can see that whole black area would normally be the view of the telescope.
I mean, the moon is there.
That's true. The moon is there, absolutely.
But there's clouds in the way. So yeah, why don't we actually show them real quick before we do some shout outs to folks. So we've got a camera right here. I'm going to move the camera upward a little bit so you can see our telescope. This is our baby. Isn't she pretty? So
Works very well when there's no clouds.
Yeah,
we promise.
it works great when there's no cloud. So this is the opening in the roof that we point the telescope to. So if there's something to see, we point that part of the roof over where the telescope is. And so we just keep moving the roof every now and then to keep up with where the telescope is.
And you can see kind of right above me here, this little piece, kind of reverse, that's a door that'll slide closed when we don't have the telescope out, but we have it open right now, of course, just in case.
Yep, so I'm doing my best not to make you all sick as I'm moving the camera. So there we go. There we go. How's that? Is that cool?
Yeah, it looks great.
And normally, light would come into the telescope and we got the camera. That is the camera right there. So we do have the camera, that blue thing. The camera is hooked up to the telescope. So we're gonna keep an eye on it because yeah.
Yeah, hey, maybe we'll have a whole sometime in this next hour.
Maybe.
So I do want to give a shout out to a couple of folks that are joining in from some different places. And I do want to say, hey, it's only cloudy in Chicago. So make sure to go out where you are right now. See what the sky looks like in your neighborhood. Look to the moon. Should be pretty high up in the sky at this point. Really bright. We've got a full moon tonight, the last of the year. So make sure to go out and check it out. Because I do see here that we have a special note from somebody in Indianapolis saying the moon is visible there right now. So that's really exciting. We've also got some folks joining us from Hammond, Indiana as well. Some places all around Chicago, South Loop, 74th and Western, nice. As well as Lyle and Naperville and West Dundee. So some folks all around Illinois and Indiana. Glad that you all could come out tonight for the show.
Where our friends in Indy, where it's clear, the occultation should be happening about the same time as it happens here. So pretty close. So yeah, if you're in Indianapolis area right now, go outside and look at the moon. You may be able to see the occultation right about now.
Absolutely.
So, yeah.
And just to give people an idea, I know that like the folks that were posting in the chat are pretty close by, but there could be some folks joining from further away. And so I wanted to let you know how you can see this occultation, where you are, how you can find out what time it will be. Because one thing with this event tonight is it happens at very different times in different places. I know the disappearance happened about 40 minutes ago, like on the West Coast, but the reappearance will be happening soon. So I'm going to pull up a site here called Stellarium. So this is Stellarium Web. This is just one that you can use just in browser. They also have a downloadable version. And we can see what Stellarium does is it gives you a live view of the night sky in your area. So if you look at the screen that I have here, you can see it's already detecting my location here in the bottom left corner. It says near Chicago. If it's not detecting yours, you can press that, choose wherever you are, and it'll show you the sky at that time. Now, since it's night, it's showing a live view exactly right now what the sky looks like here in Chicago. We can see our little friend Mars is about to be swallowed up by the moon as it passes in front of it. But depending on where you are, you could put in your location, look at the sky, and see when that's going to happen. Now, you can change the time here down in the bottom right corner to see when exactly it will happen in your locale, and then go forward, see when the reappearance will happen. This is a great tool for tonight, but it's also a really good tool just in general. I mean, me and Michelle use it every single week, seeing how high things are going to be up in the sky, all kinds of stuff. So we've got it focused on the moon and Mars right now, but you can see if I zoom out here, we've got a whole lot of sky to look at. So all kinds of things that you can use this for. But right now we're keeping an eye on Mars as we watch it go back there. Hopefully folks from Indiana can check it out.
You can change it to Indianapolis. Why don't you change it?
That's true. Yeah, you can take it on down.
Grab it. This is what we do. We have a whole script written, but we have plenty of time. So why don't we just do it for like center of Indy, right about there? Click.
I can choose the location.
Just type in.
I don't have a keyboard. Yeah, only got the mouse. Well, it should be right around the same time in Indianapolis. Yeah. It's a very similar area to us. And now we can see in the live view here that we are having Mars begin its occultation. Oh, I'm also seeing we're having some great questions coming in the chat.
All right, so we've got.
Ooh, I like this first one. So when will Mars be closest to us? So it's very timely. Pretty much right now. And the closest it came was about a week ago for this year.
Exactly. So we call that close approach. And so tonight we had Mars opposition. So that means Mars is opposite the sun in the sky. When the sun went down, Mars came up. So in Mars's orbit, there's a time period where Earth and Mars are closest to each other in their orbits, and we call that close approach. And that was a week ago. So basically, the difference between last week and tonight is really not that much.
Yeah,
so,
very little. So this is pretty much the best time that we're going to be getting Mars views this year. So
exactly. I'm going to bet it's clear tomorrow night.
And, well, hey, that's what Mars will look great tomorrow night too. As a matter of fact, if you look at the screen, we couldn't even see Mars right now. So it doesn't matter how close it is. So you'll see just in that last minute, we've had the occultation begin. Ooh, and we have a really good question here, which was, wow, doing a great job, everybody. This is the next point on my script. So the difference between an occultation, an eclipse, and a transit. So it's such a great question.
Yep.
And these are all very similar kind of celestial phenomena, right? These are all things where different objects are lining up. So there's all kinds of things that we love to look at, where, basically three objects lined up in a line in space from the point of the observer. So can you tell us a little bit about what the differences are between the three of those, Michelle?
Sure can. So basically, the phenomena are all pretty similar. So let's see. First one, we've got.
Well, we can start with the occultation. What we've got going on now?
Yeah. So we've got the moon passing in front of Mars. An occultation can be anything passing in front of anything else, blocking the view of the thing beyond. And so we can have the moon pass in front of Mars. You can have an asteroid pass in front of a far distant star. You can have a planet pass in front of another planet. So you can have lots of different kinds of occultations. This one happens to be the moon passing in front of Mars, and then as it keeps going around the Earth, Mars will reappear a short while later. So that's an occultation. So a transit is when something passes in between the observer and something distant, but that thing that's doing the passing, the blocking, is not big enough to block the whole thing. An example of that is a transit of Venus or a transit of Mercury, where Venus passes in front of the sun as seen from the Earth. The orbit of Venus would line up with the observer and and where the sun is in the sky, and you would see this little dot go across the face of the sun. So that's a transit of Venus again, or a transit of Mercury. The last time we had a transit of Venus was 2012, and the next one is in the year 2117.
For a while.
Yeah, we got a ways to go for that one. But then an eclipse is when something passes in front of something else, but the thing that is doing the blocking casts a shadow. And that is a shadow that the observer can then see. So basically, they're all very similar concepts. It's something not totally blocking something else. That's a transit. Is something totally blocking something else and casting a shadow? That's an eclipse. Is something blocking something else but not casting a shadow? That's an occultation.
Yeah, great way to explain them, man. They're all very similar concepts. But appear in slightly different ways, depending on basically the size of the objects relative to the viewer, pretty much, right?
Exactly. And we had a little discovery earlier. We were looking up the definition of the origin of the word occultation. And I'm going to go read this because I knew I was going to not remember the specifics. So let's see. Hang on. You get it? It is occultation, from the Latin occultationem, noun of action from past participle, stem of occultare, to hide or to conceal. Frequentive of oculare, to cover over, conceal. So it's all about blocking, concealing, covering. That's the origin of the word occultation. And I think the last time I used the phrase past participle is probably school. And that might be the only time I would ever.
Mine was probably the last time I took a Latin class. We might have been talking about that word even. So one thing that you mentioned when describing occultations and transits and things that I think is an interesting point that we can bring up is one that we can see here is when asteroids are going in front of stars.
Yes.
Now this is one that like the regular observer would not be looking at very often, but it comes in handy for a very particular sector of the public, and that is Astronomers.
Yeah.
So how do astronomers use occultations in their research? Like, what is the value of events like this?
They are incredibly valuable. So when, let's say you've got an asteroid passing in front of a distant star, there's always going to be some uncertainty in that asteroid's orbit. We can use the visibility of that occultation. Where was it visible on the Earth along an entire path? What was the range on the Earth where it was visible? Because then you can use that information to basically get a better sense of the refinement then of that asteroid's orbit. So that's one way it's important. Another way is, let's say we've got an asteroid, but we don't know a lot about the asteroid itself. Well, the amount of time that it could block the distant star might tell you a little bit about the asteroid's size. Or maybe it blinked out the star twice. That might mean it's actually got a companion asteroid. So there's a lot we can learn from these occultations. They are really important. There was even an occultation of a planet around another star where it blocked the light from another distant star. And we learned that that planet has an incredibly vast ring system. We could see the light from the distant star flickering for quite a while before the planet passed in front of the star. And then it flickered for a while more after the planet passed in front of the star. We were able to discern that that planet had an extraordinarily vast ring system.
Now, that occultation is really interesting to me, or all of these different occultations that scientists use, because they're really using it to look at objects that we can't see otherwise, right?
Yep.
So tonight, of course, the moon is very bright. It's reflecting so much light from the sun. So it's not so much those kinds of concerns anymore. We have such a detailed mapping of the moon these days. So we don't need to map the moon out too much anymore. But with those instances, asteroids, these exoplanets, these are things we can't see normally. The only way we can really start to discern this information is when it's passing in front of some kind of a bright object.
Yeah.
There's always going to be a star.
Yeah, if it's an asteroid, we might we'll know its brightness and that sort of thing. It'll be fairly dim. It will just be a point.
Exactly. Even the strongest telescopes, will not be able to resolve that shape.
Yeah. And so these occultations can be important in a variety of ways. Great question.
Really funny question just came in. Angela asks, are the clouds considered an occultation? I like your joke, but it hurts my heart. It hurts my heart.
It's causing a shadow. There's a shadow of a cloud under it right now. So yes, that's a great question. Who said that one? Angela?
That was from
Thanks,
Angela, yes. And we also have another interesting question here. This is somebody joining us from Naperville today, so not too far away, but a little further away from the lake, so the weather can be quite different.
Yep.
He said that he could see the moon with detail fairly well, but Mars was nowhere to be seen. What's with that? When did you look? Because if it was 10 minutes ago, then you would have seen Mars right on the edge. But now we actually are still tracking Mars here in Stellarium. So it's somewhere right around here, I think. So it's actually hidden behind the moon at the moment. So it's possible that actually Mars was already being occulted when you went out.
Yep.
Now, one other thing that could factor in is it is a full moon tonight. It's the last full moon of the year. So the moon is very bright. So it's possible that with the naked eye that Mars could be really dim if it were super close to it and very hard to see just because of the brightness of the moon and kind of washing out those smaller details.
Yeah, Joseph, if you saw it, as Hunter said, in the last 10 minutes, then yes, the moon was already in front of Mars when you saw it. So for you in Naperville, if it stays clear, and we are extraordinarily jealous, and we're going to maybe, I don't know, go on the road and go out to your house. No. But at about 10:02 p.m. or so, you may start to see, if it's clear, you may start to see Mars reappear. So 10:01, 10:02 for you in Naperville, give it a try.
And we'll definitely give a heads up, at least for everybody in the Chicagoland area when that's happening. We'll be back here in Stellarium keeping an eye on it.
Yep.
And we have another question here, and this kind of relates to some of the stuff that we were talking about earlier. Jose asked, how do you measure distances between us and planets, stars, all kinds of things?
Well,
it's a complicated question.
It's a complicated question. One of the easier ways to do it is a method called parallax. And this is the this is the way that you can kind of demonstrate yourself. And there are other ways to measure distances, but I'll talk about this one because the rest of them can start to get pretty complicated. But you can all do an experiment, right? And you've probably done this before and you didn't realize what you were doing. So I want you to stick your thumb out at arm's length, right? Close one eye and look at your thumb, right? You can probably see whatever wall or something is behind your thumb, sorry. All right, now open your eye, close your other one, go back and forth. You see the image of your thumb appear to jump around a little bit compared to the background? See that?
Definitely. Quite a bit, yeah.
Yep. So if you measure the angle of the jump, right, you might be able to measure that. You know the distance between your eyes. Okay, you know the angle that your thumb appeared to jump. If you do the geometry that way, then you can then figure out the distance between your eyes and your thumb. And so basically the same thing works for figuring out the distances to relatively nearby stars. Although with better telescopes and computers and stuff, we can actually do this in cameras. We can do this even better. If one eye represents Earth at one side of its orbit, your other eye represents Earth on the other side of its orbit 6 months later. We know that distance really well. We take an image of the star against the background stars, and then we do it again 6 months later. We measure the angle difference in between those two measurements. We know this distance, Earth's orbit. We can then figure out the distance to the star. And so that works for asteroids or whatever. So there's all kinds of stuff. There's things that but it's for relatively nearby stuff. But it's gets more complicated when you can't measure that angle. If something is too far away, that angle becomes too small to measure. Then there are other ways to start to do that. But that's the easiest way that I can get you involved in Sky Observers Hangout and have you do a little demo there wherever you are.
Yeah, even when we can't observe too much in the sky. Able to see something?
Moon's out.
Let's take a look. Show her. Maybe not too much.
It should be. Hang on.
It's lightning a little bit.
Hit the auto, click out and click back in.
Check focuser. Got it. Okay, so we're making sure that everything is in focus here because we were getting a little bit of light coming through, but still very little detail. It's possible that it could just be the cloud still. While Michelle's working on that, I feel like this is a good time to answer one of the questions we saw in the chat. They were wondering about telescope type and size. So here in the Doane Observatory, we have a telescope from a company called PlaneWave. This is a 24-inch reflector telescope. So the objective mirror, which is kind of in the back here, the primary mirror that's capturing the light there, is about 24 inches wide, so 2 feet wide. Is a Schmidt-Cassegrain type reflector. So it sends that light, projects it up to the top where there's a secondary mirror, which then projects it back down to here where we've got our eyepiece. So you can see the little camera there. Sorry, I'm not very good at pointing. Everything's mirrored on the camera. So that's kind of the light path that it takes as it comes back to here.
Keep going.
So usually this telescope does a really great job of seeing things. And actually, we even have opportunities for folks to come in and see it themselves. If you live here in Chicago, typically during this time on Wednesday nights, we would actually have. That's my screen. It's okay. I'll go ahead and stop the share for you for a second.
Yeah.
All right, so hi everybody, just me now. So yeah, typically we have the observatory open during this time on Wednesday nights. You're able to come in and see it publicly if you live here in the area. But of course, we also bring you views from here in the Doane telescope on YouTube as well. So we should be back sometime in the early spring for another show. You'll have to keep an eye on our YouTube channel to see when that's going to be coming. While Michelle works on the camera, I'm going to go over a couple of other questions that we have here. So one person was wondering how long before Mars emerges. So it actually depends on where you are. I believe if you're on the West Coast, in a few minutes is when it should reemerge. But because this is such a particular event, these objects are so far away, but the moon's so close, this is one that is very dependent on your location. And so the times differ greatly depending on where you are. As a matter of fact, this is happening like much later in Europe as well. It'll be sort of like tomorrow morning for them. So here in Chicago, Mars will be reemerging at about around 10:04, I think was the time, but it takes about a minute and a half. So somewhere right around then. And we'll let you know when that's happening. If you're anywhere here in like Chicago, Indiana, somewhere in this area, it should be pretty close to that same time frame. Someone was also wondering how much collaboration is there internationally when it comes to gathering data on a single phenomena? Now, I don't know necessarily about like a single phenomena, but this is a great question. I would say that like astronomy, there's a ton of it because location of telescope is so important for astronomy. So you think about like where all these big telescopes are around the world, and they're all in, very high altitudes, places that are typically very dry, don't often have a lot of cloud coverage. So this is places like the Atacama Desert in Chile, there's tons there, or the big ones that are in Hawaii that you've seen. So these are all hugely international projects that are taking place all over the world with researchers from all over the place. And there's definitely a lot of tracking of like single phenomena as well. So actually occultation is a really good example of things that we track like all over the world for one event. There's actually even a website that's like an occultation, like sort of a group that collects data from amateur astronomers who watch occultations like this, more like the asteroid types. And compile those all across different locations. So yeah, this is a great example of one, just like space always does, that brings lots of people together. We're all unified under the sky above us. And so astronomy is a great way to bring people together for all kinds of things.
Yeah, we definitely wouldn't be able to get enough data if it was just one telescope doing it. So they try to get as many telescopes across the whole path of where the occultation might be visible to be able to get a lot of data now.
And wouldn't you be disappointed if you spent so much time trying to do the research and it was clouded out like this? I mean, oh my gosh, yeah, they better have a bunch of telescopes ready to go.
So I'm keeping an eye. It's what we're seeing, and the reason I'm getting so frustrated is the moon is barely visible, which means it's not going to come through the camera very well. So that's why I can start to see it among the clouds, but it's not coming through on the camera just yet. So that's why I keep looking up to see.
Yeah, we're kind of taking a peek through what you might have seen earlier when we pointed the camera up here. Let me go up there again. So if we look up with the wrong remote, sorry everybody, accidentally blasted the lights there for a second. So if we take a look up, you can see that Michelle's taking a look through the big opening that we have there. Taking a look to see if we can see with our eyes, just making sure that the camera's working well and everything. Unfortunately, still pretty cloudy here in Chicago. Now, I love this question that we have in the chat too. What would this event look like if we were standing on Mars? So of course, this is all about objects lining up, right? And it's all about the perspective of the viewer. But these three objects are all in line, even from Mars too. So what would we see? Would we see an occultation?
No, we wouldn't. We would see a transit because the moon is smaller than the Earth. And the moon would be a little bit closer. What you would be seeing though, because we've got full moon in the sky here, that means the other side of the moon is in darkness right now. So you can't see that side of the moon right now from Mars. If you had a powerful telescope and you pointed it at the Earth, you would see, and basically you would have to rely on the light function of the Earth, the lights shining out into space. You would see a circular region on the surface of the Earth where you wouldn't see any lights because the moon would be blocking that. So, but yeah, you would see a dark circle transit of.
Yeah, it would actually be really close to something that we looked at just a couple of weeks ago out here in the Doane, which is we took a look at Jupiter, watched some of its moon's transit. You'll see the shadow of the little moon passing across it, just a little black fleck on the big surface of Jupiter. Kind of like that. Yeah. Kind of like that, but with the Earth. So great question. Yeah, I love that question.
Fabulous question. You know what I realized? I had to move the telescope a little bit because in the about 3-4 hours that we had it up and running, we were still tracking at a slightly different location. So anyway, I'm just going to keep looking up, and we're just going to keep checking it out.
Yeah,
So
we're keeping an eye on things for you, seeing
we
it.
missed that view of the moon, but that's okay. We couldn't see Mars because the occultation has already happened here. So anyway, we're going to keep an eye. You never know.
So we have a question on if we weren't dealing with clouds, which is a good thing to add.
Yes.
How would light pollution impact how we see the event tonight? Because that's definitely a big concern. We're here pretty close to downtown Chicago.
Yep. How would it affect it? Not at all. That's the great thing about this and why it got a lot of hype, was because the moon is bright, Mars is fairly bright. This is something you can see with your naked eye. So light pollution would not affect that. And it's actually pretty interesting that light pollution, when people think, oh, the Adler, where you get your telescope there, you must not really be able to see anything. No, we actually can, because out over the lake, it's a little darker in that direction. But also the stuff that we look at, we like to look at the bright stuff anyway. So Mars is bright, Jupiter is bright, the moon's bright, of course. Saturn's bright. So yeah, it would have been visible to just your eyes. So yes, and we have a friend a fan in
Share this out.
San Antonio, Texas.
Me here to get to share, right?
So we're gonna share the screen.
There we go.
There we go.
Just the window that y'all can see here.
There you go. We did have a fan, Martha, in San Antonio, Texas. Thank you, Martha, for sending this picture. And so if you go to the next slide.
So this is still in a pretty big city too. And this is just with a phone camera.
Yeah.
We can still see we've got the moon, Mars coming up there. This was a little bit earlier in the night before this happened. But yeah, in general, things like the planets and things that are in our solar system, light pollution isn't going to affect those too much. Even if you were in the brightest city in the world, those shine so bright in the sky that you would still see, especially the really big prominent ones like Mars, Jupiter, Saturn, things like that.
And we've also got a picture from one of our telescope volunteers, Bill, who took a picture of the moon and Mars earlier. So I'm going to grab that picture. Give me just a second. There it is. So we've got that. I'm going to check and make sure you all can see that. So it'll come through. See that. There we go. So we've got the moon, and Mars is the dot that is down to the lower left. So this was earlier tonight that Bill took this picture. So I'm going to zoom in just a bit. Go. So there's the moon. There's Mars. And in order to get both of those, the moon, of course, kind of tends to show up a little bit over space. So, but yeah. So thank you, Bill. Thank you, Martha, in San Antonio. So we had a couple of pictures come in prior to when the occultation occurred. I can see a glow in the sky. I know the moon is below the glow.
Yeah, we can kind of see a little bit of the reflection of the moon on the clouds every once in a while here in Chicago. Oh,
there it is. There's the moon.
Here's some detail of what you would have seen tonight if we had seen a little bit better. Getting some picked up here. Well, it looks like it may be a frozen image of it at this point. I don't think it's the live view that's coming through.
Hang on. Wanted to go to. Do we have any other questions that have come through while I fiddle with this?
Does look like it. All right, so we've got somebody joining us from the Ukraine tonight. They said no electricity or cloud cover for the night, so you are very, very lucky. Awesome that you've got that view tonight. Now, Jim was asking, what are the easiest items to see from Chicago suburbs with the light pollution that we do have here? Like any deep sky sites that we can see. So there are still some deep sky objects that are really great to look at, even here in the city, that we take a look at a lot with the observatory. Some of the brighter clusters will still look great. I know one that we frequently look at here in the observatory is M13. So there's definitely still some really cool objects to look at, and even lots of nebulae that can come through pretty well here in Chicago.
Exactly. We can see the center of the Andromeda Galaxy that is called M31, the 31st fuzzy thing that Charles Messier put on his list of fuzzy things in the sky a couple hundred years ago. And so that was someone who was on a hunt for comets. And so he kept coming across all sorts of fuzzy things. And he's like, well, I want to find comets. And these fuzzy things are I just need to catalog these. And so he cataloged 109 fuzzy things. And they're things like nebulae, gas clouds, the Andromeda Galaxy, various other galaxies. We didn't necessarily know what these things were at the time, but he cataloged them. And so if you see something as M42, M31, M57, those are fuzzy things that Charles Messier cataloged. So M31 is the Andromeda Galaxy. M42, which is really nice in the winter, that is the Orion Nebula. We can see that with our telescope really nicely here. So there's a variety of things we can see. M13 is a really populous globular cluster. So that is hundreds of thousands of stars in kind of a round-ish group. So yeah, all sorts.
Yeah, now of course that does depend a lot on not only your location, but the telescope you're using. So we're lucky enough to have a pretty big one here that gathers lots of light, but it really will depend on the kind of telescope you have, the exact location you're in, even like very local light pollution, just like from your backyard light, can make a huge difference. So really the best thing to do to find out what kind of deep sky sights you can see, test it out, try it out for yourself. It's really all about experimenting. As you can see, that's what we've had to do a little bit of tonight.
Exactly.
So yeah, all about experimenting. So you'll definitely have to try it out. But there's tons of things you can see.
Do me a favor, close out the camera software program there. I'm going to switch over to a different software. Hunter's going to keep
yeah, no worries.
going through the question here. I'm going to go over here to the telescope computer. So
do you mind doing it on the left monitor there?
Yeah, I will do that.
Great. Perfect. Thank you. So one thing that we were going to do tonight, while we were waiting for Mars to reappear, was sort of talk a little bit about some different things on the moon, basically give a little bit of a tour of the moon. And actually, do you mind if I take over on that computer for just a second, just to do the screen share really quick?
Yes.
Actually, do you mind if you just share the screen quickly? And what it's already set to.
This?
So open up Zoom.
Yep.
Perfect. Then go to share screen. And then start. Thank you. So what I was going to have pulled up here for us today. Oh, do you mind if I open something really quick, Michelle? Sorry. We're on the same computer with two different mouses right now. Talk about confusing. So I've got a picture of the moon. You're all good to go, Michelle. And now, of course, our hopes was to have this through the telescope tonight. But a picture does a pretty good job too. And so what we wanted to do is talk a little bit about sort of the different geology of the moon, talk about some different interesting sites on the moon. There's all kinds of like cool stuff that we can talk about, even just looking at a picture here. Now, the first thing that really stands out to me here when looking at the moon is going to be all those darker and lighter patches. And those are some really big features that we have on the moon that you can even really easily see when you look up at it in the night sky. And what's great about these is that they actually do a really good job of kind of keying us into some of the history of the moon. So they're actually really, really important, even just from the start. Now, the two regions that we can see are called the highlands and the Maria. Now, the highlands are this lighter colored part. And these highlands tell us about really the early history of the moon. So these lighter parts are much older rock. And actually, at one point, the entire moon would have been this much older, lighter colored rock. Now, one thing that you can also see here, I would zoom in, but I don't think I can steal control of the mouse from Michelle yet. So if I zoom in here just a little bit and focus on these highlands areas, we can also see, actually I'll focus in on one where we can see really detail on both. On the highlands, you can see that it's very cratered and bumpy. There's lots of stuff going on. And that's because these areas are so much older. They've had a lot more time to be kind of battered by all these asteroids over time, or other, sort of random debris in space that have come and hit it. Now, these regions of the moon were formed very early. It's about 4 billion years ago that we're looking at. And that's, in space terms, a pretty short amount of time after the first formation of the moon. About 500 million years after the moon formed, this rock that we're seeing here was starting to solidify. So that's really, really short period in terms of astronomy time. Now, one thing I'm wondering is, Michelle, why do these highlands look so much lighter than the other areas of the moon? What is making them so much lighter?
Different kind of rock. So the highlands areas, actually I'm going to go to the notes here. So and north of sites, and the that is just a lighter colored rock, different mineral formation than you've got in the darker areas. The darker areas are a type of rock called basalt.
So one that you might have heard lots of times here on Earth too.
Yep.
Lots of similar minerals between both places.
Exactly right.
And actually even lots of other places too. You know, it's all made of the same basic components, right?
So the other cool thing about the rocks that are there is what Hunter just talked about. And I want to make sure we emphasize that. We've got the same rocks here as we've got on the moon. That's really cool. And so we look for similar stuff out there in the solar system. We've got various arrangements of minerals, and we've got those same arrangements. And so anyway.
Yeah, and I have some great example comparisons later when we're taking a look at some meteorites that we have. Yep. So we'll definitely come back to that discussion. Now, the other part of the moon that we're seeing here are these Maria, these much darker areas. Yep. And definitely the first thing that I notice is how much flatter they are, how much smoother they look than the rest of the moon. You can see a few craters, dappled here and there. Of course, they've still had some time to get some in those regions, but they are much more flat since those are so much younger. Now, as Michelle said, these Maria are made of basalt instead, and that basalt has a lot higher iron content, so that helps make it much darker than the anorthosite that we're seeing.
A little less reflective, so a little more reflective for the highlands, a little less reflective for the Maria, the darker areas.
Now, one other thing that I noticed, if I zoom out a little bit here and we take a look at these different Marias, that they have pretty distinct outlines, right? And we can see that they're generally pretty circular in shape. I mean, I think this one here really stands out well. This one over here on the right side. And that really does a good job of keying us in as to how these might have formed. Because I also noticed, I saw a lot of other circular features on here, and I think they might all be caused by the same thing. So how do these Mare form? What made these new rocks come up so much later than the anorthosite?
Something smashed into the moon, made a really big hole. And so then some of that rock melted, and we've got that material came in and flooded the Maria. So that was due to essentially this melted rock coming up from below the surface and flooding that area after something from space slammed into that part of it.
Yeah, so that basalt that we now can see on the Maria was hiding away in there somewhere, seeped up through the cracks after those huge impacts, which, I mean, you can imagine the impacts to make a crater, essentially. What we would now, it's so big that we wouldn't even refer to it as a crater anymore, an impact basin, this huge on the moon. You can imagine that must have been an absolutely massive impact and really changed the moon a lot. Now, we haven't seen any of those huge impacts for quite a while, but there's lots of little ones happening all the time. Yeah, thank goodness. That would be quite the sight.
Yeah. So it's also pretty neat to take a look, because you think of the different colors of the moon. You don't think, wait, why are there different colors of the moon? And it's due to different kinds of rock that you're seeing on the moon. And we actually want to show folks.
We can, yeah. Before we do that, I want to talk about, so we've been talking about some really big, large scale geology so far, right? Looking at these big things. But there are some smaller features there, and we kind of hinted at that when talking about the Maria, talking about these as basically big craters. And so I want to talk a little bit about a couple of very distinct craters that we can see here on the moon. There's a couple of them that really stand out well. Now, of course, our hope is to show this through the telescope tonight, but this picture is not so bad. And this will help when you're looking at the
picture. Before you do that, I need to move the roof.
Oh, we should definitely do that. Yes, you go over and move the roof, and I'll get the camera pointed. So this telescope tracks automatically. It follows objects. Unfortunately, the roof does not. So we have to do that manually. But that provides for a fun moment when Michelle can show you the roof spinning around. All good. And we only need to spin it a little bit right now, since it's just been the time that we've had sitting here. Oops, excuse me. Sorry, set our camera down a little farther.
But as you can see, pointing out the opening, there's nothing.
Yeah, it's still really dark and featureless out there right now.
Review for just a second.
So I think we've got a term for those in astronomy. Those are called sucker holes. And we freaking fell for it so bad, didn't we, Michelle?
Anyway, go on. Sorry.
So the first crater that I want to kind of highlight here is this really big, prominent one that we can see here on the bottom. And this one is called Tycho. So this is a really prominent crater that we can see down here. And it's this one that I'm kind of highlighting right here. So this one is down here in the southern part. It's a pretty big one. This one's 53 miles wide, and that's pretty significant for the moon because there are like tons of craters, right? And so when going through this, I was trying to think about like, all right, what craters are we going to focus on? There are so many out there. So I checked what the numbers were for the current update. Now, let me make sure I have these numbers. So this database was from maybe 2 years ago, I think. And that showed that on the moon, over 20 kilometers wide. So that's a big crater. There are over 7,000 that we've documented, and over 1 million that are at least 1 kilometer wide. So in miles, that's a little over 1 million.
1 million.
1 million of those things on the moon that are over 1 kilometer wide.
It's about half a mile wide.
Yeah. So I mean, these are a lot of these craters could take up whole cities almost. You know, you can kind of imagine it like that. It's like little cities dotted all over the place. And it really gives you a good idea of the scale of these things, because I look at this little crater here and it looks so small when I'm looking on the moon. But that's, you know, one of the most prominent ones, not one of the million little ones that's also on there.
Yeah, just to put that in perspective, you could fit Chicago inside that crater and still have a lot of room left over.
Mm-hmm. Oh, yeah, absolutely. Yeah, tons of space left over.
Yep.
Now, one thing that I always like to point out is like, all right, so there's so many craters on the moon. Where are all the craters on Earth? What's going on? So the moon's got a few like specific things that makes it those craters don't go away. So what are the things that keeps all those craters there?
So the moon does not have an atmosphere. So there's no wind to wear these craters down. There's no liquid water on the surface of the moon. So there's no water to erode the craters away. So yeah, there's many of these processes that we have on Earth. We don't have plate tectonics on the moon, meaning we don't have giant large plates that the surface is made of, and those are constantly moving around and changing and reforming. So the moon doesn't have any of that. So these craters, once they happen, they stick around.
They kind of just stick around, yeah. And it means that a lot of like the details stay like really clear on here. So if I zoom in like even closer to Tycho, we can see some features that we see in a lot of, especially these big craters. Now, this picture, like tonight, was taken of a full moon. We can see some of the details okay, but they're a little hard to spot. We can see this rim around the edge. This is essentially the impact happens, sends this dust up, and it kind of settles around this little outside rim from the object. And you can see right there in the middle that there's a faint little bright spot. And that is a central peak that is actually at the center of it. Now, to support the views that we have here through this picture, I wanted to pull up our slides again and show these are some pictures we've taken through the Doane telescope of the moon. And these were taken not during full moons, but during other phases. And you can see that the craters really stand out a lot better. So this one here, which is just an awesome crater, you can really clearly see that rim around the outside. This one's just a little bit bigger than Tycho. I think it's about, or very similar in size. It's like 70 miles across.
Do y'all see the smiley face in the middle?
It does have a little smiley face in the middle. 2 extra little craters that happened in there. This one being that central peak. But you can see at different phases that these craters come out really clearly with those shadows. Now, we also have a little help from our friends at NASA here today, helping us out with the views of Tycho. So this is their images of Tycho from the Lunar Reconnaissance Orbiter. So this is actually something that was orbiting around the moon when taking these pictures, much higher resolution than we would get here on Earth. So here you can really see that rim in great detail on the left. And this image on the right, which is, I mean, just freaking awesome. That's the central peak in all of its glory. It just looks absolutely magnificent when you look at it like that.
One quick thing that I didn't talk to Hunter about this about, but take a look at that picture on the right. Do you see the peak? All right, and take your cursor and bring it down to the. Here, I'm gonna take hold of it. And there, right there, there's a boulder.
It's a boulder.
It's just. That boulder is huge. It's a giant boulder. But anyway, just wanted to point that out because that's kind of cool. So.
But yeah, this does a really good job of helping kind of show off some of those features. Now, another one that I wanted to point out, if we head back to that picture, another great crater that is often talked about is this one up here, Copernicus. Now, this one's about the same size as Tycho, but one thing that really stands out here, since it falls in one of those darker Maria, is an additional feature of craters that you can really see great here. All of these lines that spread out from this crater. So we can still see we've got that same rim in those little central peaks, but I love how this ray system stands out here. So Michelle, how do these rays form? What's going on here?
Yeah, so something from space smashes into the surface of the moon, stuff splashes out. If you've ever seen a slow motion video of a milk drop, you probably have. A drop of milk happens into a puddle or a puddle of water, and the water splashes out. And so that stuff that splashes out onto the surface, in this case, it's lighter stuff splashing out onto darker stuff. So, it's more easily visible.
Stands out a little more.
Exactly.
Yeah.
Yep.
Yeah, I love Copernicus for that fact that you can really see those how that ejecta is sending out. Now, this segues into the segue that I think you were going into earlier. Now, these ejecta, of course, that means that these things that are hitting the moon are hitting with a lot of force, right? To be able to send these things out. Remember that this little crater is like 50 miles wide. So these ejecta are getting sent out hundreds of miles from the initial impact. Sometimes those things don't fall back on the moon, but they end up shooting out into space.
Yeah.
And every once in a while, they might find their way here to Earth.
Right. So that stuff doesn't just go out, it goes up. And so if it's going fast enough, it's going to escape the moon's gravity. And it's going to travel through space and possibly intersect with the Earth. And if that piece happens to be big enough and it survives all the way down to the surface of the Earth, we can find it as a meteorite. And we happen to have.
We got one of those right here with us today. Do you want to show that off a little bit on camera before I switch over to our? So we've got some microscope views that we'll provide here. But you can see this is our little piece of the moon that we've got here, out here at the planet or at the observatory.
Yep, and maybe if you come visit us sometime here in the observatory, we might have it here.
Sure.
Just say, hey, I saw you guys at Sky Observers Hangout. Can I see the piece of the moon?
Oh, and we'd be happy to bring it out just for you.
Absolutely. We can touch it. You touched a piece of the moon that is theoretically in the sky. Go ahead and switch over to the
Oh, yeah, absolutely.
Shoot.
Too late. Well, yeah, I had to. Do you mind bringing the window over here? Thank you. Just put it right in front of the PowerPoint. Taking a look, making sure we've got the camera. There were some sucker holes, but we wouldn't mind a sucker hole that we can see through for at least a minute. Now is definitely the time that we want to start seeing them, because if you're keeping an eye on the clock, 9:52 right now. So if we head back to Stellarium here, we can see this is where Mars is at the moment. It's getting closer and closer to the other side here. And nothing. You're controlling it again. While we're loading this up and working on the camera a little bit, I do see that there's a couple more questions that have come in. I apologize, I didn't get to some of these sooner. One person was wondering, can this only happen with a full moon? How would it appear if the moon was in a different phase? So this can happen during different phases of the moon. It doesn't necessarily have to happen during a full moon. And there's occultations happening every night with the moon in particular, right? It's crossing many, many stars and things. Now, even if the entire moon is not illuminated, right? So we can't see it from where we are. That doesn't mean that the rest of the moon isn't there, right? So even the dark part that we can't see, when you're only seeing half of it, that other side, it's all still there. Are you gonna stop sharing?
Can I stop sharing the camera? Is that all right?
Here, I can actually just minimize it. It's okay. So even that dark side of the moon would still cover some things up if it was in the way. So you would actually still see an occultation. You just wouldn't see the moon that was actually covering up, in this case, Mars, but whatever object you were looking at. So you would see Mars disappear, but seemingly as if it was disappearing almost behind nothing.
Yeah,
point, right?
yeah, exactly. So you'd see the dark part, but the lighter part, it might reappear on that side, or maybe the other way around, depending on which part of the moon was lit up at that point. So anyway.
So great question.
Yeah, excellent question. And I apologize to folks because you see me jumping up every now and then. The moon is visible for so short of a period
Such
of
a
time.
short amount of time.
By the time I'm getting up there to adjust the focus on the camera, it's gone. So
Yeah.
this is what we're dealing with tonight, which means
Classic sucker holes.
Oh
Classic sucker
my
holes.
goodness. Anyway, go ahead. So do you have more questions?
Yeah, sure. Oh, I was going to say, when you
Okay.
come back to the meteorite here, just for a second, because we were talking about it before everyone forgets. So what we're looking at here is this meteorite through the microscope. And so there's a couple of like interesting features that we have here. And one thing is some of the minerals that we're finding inside. Let me switch back over the camera. So one thing that we're seeing is the minerals that are inside. Oh, you're changing the
sorry.
screen share. It's okay.
Sorry,
It's all good.
just grabbing the camera software. Oh, yeah, sorry.
You want me to open the camera software up and throw it over there?
We've
There
got,
you go.
we got four
You got it
different
over there?
screens in this room right now, so we're playing along with all of them.
Yeah, apologies. We're sharing from one, but it's projecting many things. You can use the mouse going at. So one thing that we're looking at here with this zoomed in is you can see some different minerals, and this tells a story a lot about like how this would have came to us. So this one that we have here is gabbro, is the rock that we're seeing here, and that's basically a kind of basalt. It's a coarser grain basalt, so it cooled a little bit more slowly, probably beneath the surface rather than on the surface like the Mare. But that does tell us that it's coming from one of these Maria, maybe like the one that Copernicus crashed into even. You know, it's very possible that could be the event that it would happen at. It would be at some kind of really large event like that would send it out into space. Now, one thing that we can see here is we've got these little flecks of what's called olivine. This is this yellow-green mineral that we can see in there. And what olivine is this is a silicate that we can also find very frequently here on Earth and in a ton of different meteorites from all kinds of different stuff. We've got a Mars meteorite that we have here from the moon. And this silicate comes up on Earth from lava flows, brings it up because it's stored mostly in our mantle. And so it's a very similar thing that probably happened here with the moon, why you would find it with that basalt.
Some of you may even be wearing olivine right now, because olivine in the gemstone world is peridot.
Yeah, you can have it on your jewelry. Yeah, absolutely.
Yep. So if you have the birthstone peridot, you are wearing olivine. And this is olivine, of course, from Earth, but we do have olivine in meteorites, and which means it exists as rock on other worlds. And so we find it on Mars, for example.
Yeah, another feature that we can see here that I really love is this big black line that you can see like almost cutting through the meteorite. You can see it a little bit more zoomed out here. So this looks almost like when you look at it on the actual meteorite itself, just like with your eyes, it almost looks like a little crack, right?
Yeah.
Can you tell us a little bit about what we're seeing there? What is that black line that goes through it?
Yeah, so I can actually see it right here when I'm looking at the meteorite. So
Might be hard to pick up on.
yeah,
camera, though.
it will be. But that is called a shock vein. And what that was caused by, that black line did not exist in this rock when the rock existed on the moon. What happened was the rock from space slammed into the surface of the moon, put so much heat and pressure into that rock on the moon that it essentially melted. The shock melted some of the rock in that line. And so when that rock got blasted off the surface of the moon, traveled through space, landed on the Earth, we can see the result of the impact melted into the interior of this rock. And so that is a shock vein. So yeah.
Yeah, it's a great feature to find on a meteorite. It's a kind of a unique one to find on there. We do have a couple of questions, and one that's very related to this. Do we know if the moon has a molten mantle? So I was talking kind of about the molten mantle here on Earth. Does the moon still have one?
I believe so. I don't honestly know if it's molten. Hopefully Gaza can help answer that question.
True, he may have already helped answer this.
Yeah, but the question then is, if it is molten, could that material then make its way up to the surface in any way? And the answer is probably not. So if it has a molten interior at all, then it's unlikely that stuff would make its way out. There just wouldn't be the ability for it to happen.
Yeah, there'd be very little these days, if any at all. I'm not sure how much there is, if there is any. But great question.
Yeah.
Now, another question here, and I think that kind of wraps up what I wanted to talk about with the meteorites here. Another great question that I saw brought up was actually about some missions related to the moon, which was something that we were going to talk about, which honestly we don't have a ton of time for. It's already 10 o'clock. I can't believe it's as late as it is. I feel like we've had so little time out here, we haven't even been able to see anything.
Time to see the moon for a grand total of maybe about one.
So this question was, is Artemis doing any astronomy experiments? And then another question was, do we coordinate with Hubble or James Webb? So maybe you can answer that a little bit while I work on the slides here. I think the big one is Artemis doing any astronomy experiments? I think that's the big question here.
Don't think so. There were some experiments that tagged along. There were some CubeSats, small satellites that tagged along on the Artemis mission. I don't remember if there are any astronomy missions, but if NASA does that sort of thing, sometimes they do. They call those missions of opportunity. And what that means is, hey, we're sending something in this direction. Want to go along for the ride? And so sometimes they'll add some experiments onto some spacecraft. So I don't honestly remember if Artemis has anything like that, but it could very well happen in the future if it doesn't. Because, like I said, they've already got the spacecraft. If they got a little extra weight that they can bring along, then sometimes that sort of thing happens. And then coordinating,
coordinating with Hubble or James Webb. So I don't know if that was referring to Artemis itself or us here at the Adler. Now, of course, Artemis, Hubble, James Webb, all these things are primarily NASA projects.
Yep.
So they absolutely are coordinating with each other, but they really have very different goals in mind.
Yeah.
Right?
So Hubble and Webb, so the Webb telescope and Hubble can look at the same phenomenon or the same objects, and they have. So when the DART mission, the mission that impacted an asteroid a few months ago, the impact happened, and Webb and Hubble were both looking at the target asteroid as the impact occurred, and then the aftermath as well. So that was the first time that those two telescopes had been looking at the same thing at the same time. And so they anticipate that will happen more in the future. But that was the first time that had happened. And yes, they do coordinate. And actually, it's very easy for them to coordinate because they're both run by the Space Telescope Science Institute, which is at in Maryland. So it's pretty easy for them to do that because they're both under the same roof.
Yeah, and as a matter of fact, a lot of the initial objects they looked at with James Webb were things that they had very diligently researched with Hubble already to kind of compare and see how it is. Now, I also wanted to go back to Artemis a little bit just to bring us back to the moon here. So, and kind of also follow up with that question about doing any astronomy experiments. So what we're seeing here in this picture is Artemis 1. Now, it's important to note that this is just mission 1, and there's a lot more Artemis to come. So we can see the takeoff that happened just a few weeks ago, and then we've been getting some awesome pictures coming back from Artemis. I chose this one because I thought it was great to have two of the objects that are lining up tonight, the moon and Earth, as seen from Artemis. And what this first flight is this one is an unmanned spacecraft. There's nobody inside this right now. This is really their first test run. So they're trying to see how well is the shuttle working. And after many clouded or mistaken attempts, they did finally get it off, and it worked great. And so far, their orbit around the moon has been going really well. So this is an unmanned craft that is going to orbit the moon a couple of times, and actually, it's heading. I think it's back towards Earth at this point. In 4 days, it'll land back here on Earth. So that is exciting. We'll definitely be keeping an eye out on that. Now we've got more Artemis missions coming up. So what do we have to look forward to with the Artemis mission?
So the next one is Artemis 2, and that one is slated to happen sometime, we hope, in 2024. And that will be a crewed mission. So the last one was the current one is an
So I just wanted to point out, I switched over to Stellarium. Sorry to interrupt. Mars is peeking out at this moment. So if you can see it, go outside. We can't, but there it is, starting to come back out.
Our friend in Naperville, go out and tell us if you can actually see this.
Anybody in Naperville, go out there.
What you're seeing is Mars just start to brighten up as it reappears. And so this is happening in the Chicago area right now. So if it happens to be clear, go outside right now and tell us in the comments, in the chat, if you can actually see this. So we've got, switch over real quick.
Yeah.
So.
Oh, you mean the camera? Sorry.
Yeah.
Grab it and bring it over. Apologies. Yeah. You want to do it? Thank you.
So hang on. Nope.
Nah, still
Wait,
can't.
wait again.
Can't see it through the
Oh my
telescope either.
goodness,
Still.
this has seriously been happening all night.
But here it is. I mean, that was our big moment, though. Here comes Mars. It's back out.
There we go.
It has reemerged. So before we go,
So Artemis 2, sometime in 2024, and that will be a crewed mission. It's not going to land on the moon. We hope that will happen as early as Artemis 3.
I want to point out crude is in CREWED,
Correct.
not CRUDE, because
Correct.
I will say that's how my brain thought of it for the first.
Yes, correct. So with A crew is the current one. With A crew is the next one, but not landing on the moon. And then hopefully as soon as Artemis 3, it's supposed to be in 2025. It'll probably be more like 2026 when that happens. Because honestly, these missions are complex. They are difficult. They are going to be using technologies that are brand new. We're going to be landing on a place on the moon that we've never been to before, which is the South Pole.
Yeah, so they'll be landing them down here, whereas previously, all landing sites have been very central around the equator. So it's super exciting, and I really hope that it goes as spectacularly as I'm feeling it will.
Hope so too. So if anyone can do it, NASA can do it. And thank you also to the European Space Agency, which is playing a giant part in this mission as well, because the service vehicle that basically would keep everybody alive to help keep everybody alive in the spacecraft. That service vehicle is built by the European Space Agency. So thumbs up to our partners over in Europe.
Yeah, it's really a hugely international partnership, and with the final goal of setting up a more permanent presence on the moon. That will certainly be a huge international effort, just like the space station, where we have astronauts constantly stationed at these days.
Exactly. All right.
Well, I think with that, that is our views for the night, or at least the best that we're gonna get for today. As we often say, we hope for clear skies next time, right? Well, hopefully you'll all be back joining us in January of 2025 for the next lunar exploration of Mars. Yes, we'll be here for this same moment.
However, Sky Observers Hangout will be here prior to
long before then. Yes, long before then.
I'll get you a sneak peek as to what we're planning. So between the middle of January and the beginning of March, if it's clear out, we're going to at 9 p.m. Central Time on a Wednesday night between January 18th and March 1st. If it happens to be clear out, we will throw a camera on our telescope and just start up a Sky Observers Hangout just to give you a little tour around what's going on in the night sky. So those are just going to be Sky Observers Hangout of opportunity. If the sky is clear, not like tonight where we know the phenomenon is happening, but we can't see it because of the clouds, that will happen if it's clear. So keep an eye on the Adler Planetarium's YouTube channel because we will post with a day or two's notice. We're going to post whether or not we're going to do, or if we are going to do one of those shows. So if you don't see a post, if you don't see a YouTube calendar entry for it, that means it's probably not going to be clear, so we won't do it. But we're going to keep our options open for those.
Yeah, definitely. So one thing you can do is if you hit the bell next to the subscribe button, you can get notifications for our YouTube. You would get a notification when we publish that. And I'm sure there will be things on our other social media platforms as well, advertising that. That one will be a lot different than tonight. There's not going to be any specific, big celestial event we're looking out for. It's going to be us looking at lots of different objects. We're only going to do that if it's clear outside, so we can guarantee some telescope views if we're live then. So definitely keep an eye out for that. And yeah, just as a reminder, make sure to subscribe down below so that you can see all of those awesome updates when we have those coming. One other thing, if you enjoyed this program tonight, consider donating to our year-end campaign. It's here in December right now. And so I just wanted to point out our year-end campaign, Space for Everyone. Each and every day, you help us create space for everyone in Chicago and around the world. When you make a donation to the Adler Planetarium, not only are you directly supporting Sky Observers Hangout, but all sorts of stellar in-person and digital programs here at the Adler. Things like our new original Sky show coming out in 2023, all of these digital programs, new exhibit spaces that are in development. There's tons of awesome stuff going on at the Adler right now. It's a really exciting time. So it's a great time to donate. Help us raise $150,000 by the end of the year is our goal.
Exactly. And so we are going to give one of you the last word in Sky Observers Hangout tonight. We have one final question. So Edward asked, did Mars hit the moon? Or maybe another way of putting that is, how far is Mars from the moon tonight? So did Mars hit the moon? And the answer is no, because Mars is so much farther away than the moon is. Our moon is about 240,000 miles away on average. Right now, tonight, Mars is about 50 million miles away. So no, short answer, Mars did not hit the moon because it is so much farther. But isn't it amazing that we are all here tonight just to try to get a chance together to learn a little bit about our universe. And we hope you had fun, even though we couldn't show you the occultation itself. That's okay. Your questions were fantastic. Thank you.
Absolutely. Yeah. And a great way to answer the question about did Mars hit the moon after the show's over. Hopefully it's clear where you are. Go out and check. See if you can see Mars up there in the sky. Jennifer's going to post a feedback survey in the chat right after our program is finished. Let us know how we did. Let us know how you think we could do better in the future. You can even leave us some recommendations for things, for topics that we can do in the future for Sky Observers Hangout. We've got lots of shows where we will hopefully see you then. Other than that, thank you all so much for joining us at Sky Observers Hangout tonight. I think that's us signing off here, Michelle, right?
So we'll leave the chat open for just a few seconds longer as we sign off and we start to warm ourselves up. So thank you so much for joining us. This has been a blast. Thank you.
Yes, thanks so much for joining us tonight, everybody. Have a great one. Clear skies.
Good night.